You know, physics has given us this incredible, almost godlike power to predict how the universe works. But what if all of that success is just us getting really, really good at mapping shadows on a wall? In this explainer, we're diving into a pretty provocative idea that maybe we've stopped trying to understand the engine of reality itself, and that it's time to start figuring out how to build it. Let's get into it.
Our theories are just ridiculously powerful. I mean, we can predict the behavior of entire galaxies and the tiniest interactions of subatomic particles with absolutely stunning accuracy. But here's the really unsettling question that this whole explainer is built on. Does predicting how something behaves actually mean we understand what it is? That's the core problem we're going to unpack today.
Okay, so before we dive headfirst into the problem, we have to give credit where it's due. We have to acknowledge the absolute, mind-blowing triumph of modern physics. It is a staggering achievement, giving us a real grasp of reality, from the smallest quantum jitters to the vast, sprawling web of the cosmos.
And the sheer scope of this success is just breathtaking. You've got general relativity on one hand, giving us these elegant laws that govern stars, galaxies, the very fabric of spacetime. And then you have quantum field theory, with its bizarre and beautiful rules for the whole subatomic ballet. The predictive power we've gotten from these two pillars is honestly just astounding.
And yet, for all these incredible tools, there's this growing feeling, at least for some physicists, that we've kind of stalled. Not in our ability to crunch the numbers, but in our ability to truly understand. After decades of these massive, expensive experiments that haven't really yielded any new fundamental breakthroughs, it really feels like we've hit a conceptual ceiling. The path forward isn't just about better math anymore, it's about asking a much deeper kind of question.
So, let's get right to the heart of the issue, what the source material for this explainer calls the great omission. And it all boils down to this critical difference between describing what happens and explaining what's actually there making it happen. This slide just illustrates the whole idea perfectly. Our current theories, they are absolute masters of description. They give us the formal rules, the math that matches what we see, the shadows on the wall, flawlessly. But they are almost completely silent on the explanation. You know, the actual stuff, the machinery, the engine that is casting those shadows in the first place.
This quote really frames the challenge ahead. It's an ancient analogy, but it's for a very, very modern problem. The argument is that the next great leap in physics is going to require us to turn away from that wall and finally have the courage to ask, what is the real object, the real machinery, that's creating the patterns we've gotten so good at mapping?
Now, I know this might all sound a bit abstract, so let's look at a perfect, concrete example. The mystery that sits at the very heart of the matter we are all made of. Let's talk about the fermion.
So what even is a fermion? Well, simply put, it's a category of particles that includes things we're all familiar with, like electrons, protons, and neutrons. Basically, the fundamental building blocks of almost everything. This is the stuff of our world.
Now, every single fermion has this really bizarre property called half-integer spin. It's a number that just pops out of the mathematics, and it perfectly describes how they behave. For example, it's the reason that two electrons can't be in the same state at the same time, which is fundamentally why matter is solid and why you can't just walk through a wall. But here's the catch. It's just a fact. It's a label. It doesn't explain why they act this way. There's no mechanical picture behind that number.
And this quote just cuts right to the chase, doesn't it? We've become so used to the label that we've started to think of it as an actual explanation. But it's not. It's like describing a car by just saying it's a thing that moves, but never ever mentioning the engine or the wheels or the fuel.
So here's the crucial point. Saying a fermion behaves like a fermion because it has fermionic properties, well, that's a completely circular argument. It's a tautology. We're just defining a thing by its own behavior, which tells us absolutely nothing new about what it actually is.
This is the one question that just stops our current physics in its tracks. It's not asking for a better prediction, it's asking for a physical picture. What is the actual tangible machinery that produces this weird behavior we call half-integer spin? Right now, we just don't have an answer.
So, if just describing things isn't enough, what comes next? Well, according to this perspective, the next great frontier for physics is to move from being an observer to becoming a builder. To start, actually constructing the machinery of reality itself.
This is a pretty radical call to action. It's suggesting that a theory isn't good enough anymore if it just gives you an equation that happens to match the data. The new goal is to propose a real, tangible mechanism from which the incredibly successful equations we already have can be derived as a natural consequence.
So, what would this new kind of theory even look like? Well, it would have to do three big things. First, it would have to propose the actual stuff that reality is made of. Second, it would need to show how the laws of physics that we know and love naturally emerge from how that stuff behaves. And third, and this part is just fascinating, it would have to explain us. It would have to explain why our way of looking at the universe, the scientific method, works so darn well in the first place.
So what does all this mean for the future of physics? It's really a profound shift in identity. It's a call for physicists to become architects, not just cartographers or, map makers.
This slide just sums it up perfectly. For the last 100 years or so, the goal has been to be a cartographer, to map the terrain of reality with incredible precision. The new mandate is to become an architect, to understand the bedrock, draw the blueprints, and actually build a working model of the very machinery that makes the terrain what it is.
So the new directive is pretty clear. We have to demand that our theories make sense on a fundamental physical level. That's what people call ontological coherence. This idea that a theory has to describe a coherent, existing reality, not just predict outcomes. We need to answer how does it work and what is it made of, not just what happens next. And look, this isn't just a fantasy. The source material points out that theories trying to do this, like the one in the book New Perspective, are already being worked on. This really is the great challenge for the next generation.
And that leaves us with this final thought. Physics has given us a beautiful, intricate, and remarkably accurate map of the shadows on the wall. The question for all of us now is, are we satisfied with just having that map, or do we have the courage to finally turn around and figure out what kind of incredible engine is casting them?